we have to find out what else we can do with delegates. And yeah, now it's not that basic anymore. Now we will discuss some topics which are a little bit more complicated. But before we go into these topics, we will take a look at dnSpy, because I now downloaded dnSpy using my own mobile phone, and now it worked. This is dnSpy, you see? And in dnSpy, I can simply open the compiled version of our code. So if I take a look here, I can paste in the folder and go to, oops, wrong one, go to bin, debug, netcore app. Oh, we are currently 3.1. We will have to change that to 5.0 in a few minutes, because up until now we only used features of C#8, but now we will switch to C#9 in a few minutes. But still, that works perfectly fine here in dnSpy. As you can see, now I have my application here, and if I zoom in a little bit, oh, here it is, program, and then we'll take a look at the intermediate language. Up here, you can change the intermediate language. And here you see some things. I think I didn't compile yet. That's the problem. Let me recompile. I'm sorry, I didn't compile yet, so I was looking for types which aren't there. File, reload assemblies, and lambdas and delegates, and let's see whether something changed. Main. See that one? dnSpy is so intelligent that it recognizes that we have used a lambda function here. But here, the code does look a little bit differently. If you take a look, it says new mathop program add. If I go here, you see I just passed add. So the code looks a little bit different. But if we switch to intermediate language, IL, here, then we will find in reality, if we take a look at the main method, for instance, and if we scroll down a little bit, then we will find out that the system calls mathop, let me quickly see if I can find it. That's the line 15. It's not that easy to read, so it always takes me a while. Yeah, here you can see it. This, for instance, if you take a close line at the intermediate language code, then you will see that, where was it? Here. That here we are in line 15. And line 15 is that one with the multiplication lambda. You see it? Yeah. And if you take a close look, then you will see that it still generates a mathop lambda, but here you see that the code is not inside the main method, but it calls a function which has a very, very strange name. You see that one? That is a function name. That's really a function name. It's very strange. It was chosen by C#. And here we can take a look at these functions. You see it? Yeah, we can take a look at these functions, and we will see that it does an add, see that one? It does a subtract, this one, or it does a multiplication, see that one? So C# is just pretending, it's just pretending to have these lambda functions, but in reality it generates a separate type with separate methods and chooses very, very strange names. See that one? These are the function names, these are the delegate names, very strange names, but we don't have to care. And the power of dnSpy is, if you click to C#, you don't see the generated code. But if you want to dive deep, you can switch to IL, and then you see all the crazy details, what the C# compiler does behind the scenes. Get it? This is what I wanted to show you. So that was the proof that writing it like that is exactly the same as writing it like that is exactly the same as writing it like that. Well, the last thing is not really true, not completely true, but yeah, for now it's perfectly fine. Understand that? Understand the reason of D and SPI? Do we have a lightning talk or something about D and SPI? Anybody chose? I think I have D and SPI in my list. No? Oh, then it was good that we take a look. But still, if you want to do a lightning talk about D and SPI, now you have seen it, maybe it raised your interest, choose it, because D and SPI has a lot of interesting tricks in its toolbox, and therefore it would definitely be interesting to watch a lightning talk 7 minutes about what you can do with D and SPI. Good. Questions? Nice. The next thing that we have to understand about delegates is that delegates work very, very well with generics. Now, I'm not sure whether you all understand what generics are. Can you give me an indication? Let's do the same exercise again. A student from a lower class comes to you, blah, 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 asks you, what is a generic? What would be your answer? Many people make generics so complicated, but generics are rather simple. Generics enable you to pass in a type to a function like a parameter to a function. Let me show you what I mean. We can write delegate int combine int. I will use A and B just to have a difference before. If I write a combine function, not a math operation, I can now, these are called parameters, right? We all know that. A and B are parameters for this function. And now with generics, we can simply add type parameters. We can not only add value parameters, but we can make the type a parameter. We can say, here we get a type T. It's typically called T. And then wherever we have types, we can use the type parameter T, T, T. So now we have a method which has two parameters, A and B, and the type of the parameters are a parameter to the method too. Understand what I mean? It's like a parameter, but a type. And therefore, question, does our add method here fulfill the contract of the combine delegate? Why? They get an integer, they get a second integer, and they return integer. They have 3 times the same type, int, int, int. If I would change something here, float, would now the add method fulfill the combine delegate? No, because we don't have int, int, int anymore. And if you take a look here, this parameter T is used here, here, here. So the combine method says it gets 2 parameters of the same type and it returns the same type. And in our case, we now have an int, int float. And that is not a combine method anymore. If I change that, does the add method now fulfill the combine delegate? Exactly. Thumbs up. Yes, it does. Because it gets a float, float, float. Would a string, string, string fulfill the contract? Yes, of course. Would a person, person, person class fulfill the contract? Yes, it does. I think you get the point, right? So a delegate, a generic delegate is just a function where not only the value parameters are parameters, but also the type of the parameters are parameters. We call them really type parameters. This here, let me undo the int here, that's good. This here is, this here is called a type parameter. Yeah? If we understand that, now let's take a look at the calculate and print method. Let's take a look at that. Please take a look at this implementation and tell me, does it really matter for this method whether x and y are of type integer? Would it change anything if x and y would be floats? No. If it would be a string? No. If it would be a person object? Nope. Doesn't matter. It's always the same. Why do we have to add a calculate and print method over and over again for any type? If we would have a second version of this function which would work with strings, don't do that now. I will really, it's a mistake what I do here. If I change that one to string and I change that one to string, would it really make sense to write a calculate and print int and a calculate to print string? It doesn't make sense because the code is exactly the same. I understand that you have a question. Let me quickly fulfill the train of thoughts here. So let's take a look at the following. And now it becomes a little bit complicated. I know that, but stay with me, okay? I can add a type parameter here. I can add the type parameter here. I can add the type parameter here, and I can replace the math op with combine with the type parameter here, and suddenly we have a calculate and print method which works with any type. It works with int, it works with float, it works with string, it works with anything. Let me prove that. Let me prove that. Calculate and print. A, B, x, y. Now they are a string. So I can say x plus y, but if I hover over y, it will tell me that I will now concatenate strings. Calculate and print. True, true, x, y, x and y. We do a binary operation. Sorry, I forgot a comma. Now it works with Boolean. Perfectly fine. Let's check out what the compiler really does now. The compiler will now try to find out, for instance here, what is the type of x? Okay, let's take a look. X is part of the call to calculate and print. Calculate and print can be found here. Now it takes a look at the third parameter, combine. Can it find out what combine is? Yes, of course, combine is exactly here. Now it takes a look at the first parameter because x is the first parameter, and it finds out that the first parameter, oops, it's not defined yet. It's t. So it walks back and takes a look. Where is t? T is a type parameter here. So it takes a look at this call here, up here, and looks, did the programmer give me a type parameter here? No. The programmer didn't give us a type parameter, so we have to do another step. It finds out that the first parameter here also have this t. So it takes a look at the first parameter of the call, which is here true, and now it understands, by following this logical combination, it understands that in this case, in this call here, t, the type parameter t, has to be a Boolean. And therefore it knows that x is a Boolean, y is a Boolean, the result has to be a Boolean, the f is a function which returns Boolean, and it can really compile everything in a type-safe manner. If I would mix things, something like this, it wouldn't work because it has no understanding. Here we tell him that t is an int, and here we tell him that t is a Boolean. And that is an error. That can't be true. It can't be Boolean and integer at the same time. Whew. That's not that simple, is it? But it's super powerful. It's so powerful because now we can write algorithms which can be used in a very generic way, in a very broad way. And modern C# code, you will find this over and over again. If you take a look at the code in GitHub of modern libraries, this is how modern C# looks like. This is how you write modern C# code. You will find lambdas, generics, generic delegates all over the place. Immediately, when we take a look at ASP.NET, at web APIs, web applications, everything, you will always see these generic delegates. You will rarely write them, but you have to understand them. So we had a question, right?
Yeah, is it possible that I say T should be a part of a number or something like that?
Yes, that's possible. That's possible. You can, for instance, say T must be a value type, or T must be a class, or T must be a class with with a constructor without parameters. T must implement a certain interface. Yes, you can do that. You can do that. I will not do it now, okay, because it's rather complicated syntax and I have to build a lot of steps. But yeah, yes, it's possible, definitely. By the way, we could definitely pass in the type here as a parameter. We could say bool here. That's fine. That's no problem. It's just like before. We can say bool here too. That's perfectly fine. If we want. It's not necessary, but we can. The same thing applies that I told you previously about it depends on what you want to do. So, in many cases throughout this course, it will not be necessary that you write something like this, or that you write something like this. In, I would say, 90 out of 100 cases, you will just use types, classes, things that Microsoft built. But the problem is, if you don't understand what this stuff is all about, you cannot read the documentation, and you cannot apply these libraries. Only if you get very, very deep, if you want to be a professional C# developer, then you will probably also write such constructs. But if you want to get through this course, in many cases, you need to be able to understand these things, to read the documentation. Good. I give you another few moments to take a look at the code, and maybe you come up with a question here. Let's do a small exercise. Let's start with a new console app, and this time we are going to build something which makes a little bit more sense, okay, than this simple add method, and with something where we can apply all the things that we have learned so far. Good. I will save this project and I will check it in later on so that you will have it, or did you already follow along? Okay, nice. So if you want to follow along, and I encourage you to do, please create a new project, again, a console app. This time we will call it Lambdas and Collections. Lambdas and Collections. And this time, please right-click on the project, go to Properties, and change to .NET 5, if you already have it. If you don't, yeah, I can help you overcome this problem. But you should, because it was your homework to install it. .NET 5. Additionally, okay, I will wait a second until you completed it.
How do you change to .NET 5?
Right-click on the project, Properties, Application, target framework. Here, application, target framework. Did you find it?
Searching right now.
Yes. If you can't find this setting, there is another way too. If you are on .NET 3.1, you can simply open the csproj file. That's the project file, and change that from .NET Core App 3.1, I showed you that last time, to .NET 5.0. That's the same. Did everybody manage to switch to .NET 5?
No.
No. Can I help you?
No, I think I have to update my computer.
Ah, okay. That would have been your homework, but please do it until... Huh?
It worked.
Okay. A new version of Visual Studio, by the way, came out, I think, yesterday or 2 days ago. Yeah, but whenever you have time, install it. It's a small update. It's not a large one. Okay, so if you don't have .NET 5 running on your computer, please do that in the homework. Stick to .NET 3.1 if you can't do that. Additionally, I ask you in the csproj file, and I think you have to do that manually in the csproj file, you add the language version preview, because we are going to use the latest and greatest C# stuff. This is csproj. If you want to know how to open the csproj file, just if you are in the CS file, just click on the project and it will open automatically. Of course, you can also use any other editor to open it. So I will wait a second. These are the two settings which we are going to use. And get used to them, because we will use them over and over and over again. Did everybody find the setting and change the settings accordingly? Nice. Good, 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 good. Now, let's do a little bit of C#9, .NET 5, Lambda, and collection stuff. The first thing that we are going to do, delete everything except of using system. In .NET 5, it is no longer necessary to write a main method. If we just want to write a bunch of statements, we don't need a class, we don't need a main method, nothing like that. Maybe you have seen the video that I gave you on Flipgrid. There I describe this feature. It's called top-level statements. Microsoft wants to make C# simpler for very, very small demos, and this is a very small demo. Okay, good. Let's create a small data structure. And I've seen in the GitHub repository that nobody of you, in terms of C# recap, has chosen the records feature. So let me quickly describe the records feature. Please do not follow along until I tell you, because otherwise you will have to delete a lot of code. For instance, if you want to maintain a list of, let's say, heroes, okay? I can create a class, hero. Of course, that's possible. And then I can create a bunch of properties, maybe string first name, and property string last name, and maybe a property string hero name, and maybe a property boolean can fly, something like this, okay? But that's not really a good solution, because we would have to create, if we want to write beautiful C# code, a constructor. Please don't follow along. I will delete all this code in a few moments. And then I can pass in some parameters here: string first name, string last name, string hero name, and boolean can fly. And then I will have to assign all these things. First name equals to first name. I think you get the point, right? It's boring. And then I will have to remove these setters because they are set in the constructor. It's so boring. Because if I want to write a really beautiful class here, I would have to do additional things with which I don't want to bother you. The point is, with .NET 5, we can simply boom, get rid of that. We don't need it anymore because now we have records. We can write record. Now you can follow along. Hero, round brackets, string, first name, string, last name, string, hero name, bool, can fly. Bang, done. A record is just a class. It's just a class. But all the stuff that I showed you before with the constructor and the properties and all this stuff, it's done automatically for you. Really nice. It's a new type of class in .NET 5 which saves you a lot of typing work. Got it? Question?
So a record is just basically a data capsule.
It's basically, in the first preview versions of .NET 5, it was called a data class. It's just a class holding a bunch of properties. That's a record. That's not completely true because it's really a class. I could, don't follow along, I could open the curly braces here, and this is now a regular class. Add methods, add properties, do whatever you want. But you don't have to write the constructor, you don't have to write the properties, that's done for you. Okay? That's a record. So whenever you need a simple data structure where you just want to store a bunch of strings, int, state times, whatever, create a record and you're done. Saves you a lot of typing. Got it? That's records. Of course, there is much, much more to it. I did a full day workshop this week at a conference, and of course it will be on YouTube. So if you want to dive very deep into this stuff in a bunch of days, I think in 2 weeks, I will have all these videos online. It is a 6-hour course about what's new in C# 9. Party on. If you want to take a look at it, you can. Good. Now let's create a bunch of heroes, okay? Var heroes. New hero array. Now let's create a list of hero. It's better like that. Sorry, just changed my mind. What you need to add in order to create a list of heroes is you need to add a using. This is why I just added a list. Let me show you how I got this using for those of you who are not that familiar with Visual Studio. Visual Studio shows you that there is an error. It doesn't know what list is. And then you can press Ctrl dot. It will open up this nice little light bulb, and then it offers you the using, and you just click on it or just press enter, and it will insert the using automatically. Got it? There is another nice feature in the latest version of Visual Studio. If you just type list of hero, the light bulb appears here, and you can immediately, whoops, I'm sorry. I clicked on the wrong menu item again. So if you type here, the light bulb appears automatically. Just click on it and it's done. Now we can create a list of heroes. Let's create a hero. You can write it like that. You don't need to write the type again. That's also new in C# 9. You just say new, and C# is smart enough to recognize that this is a list of hero, so this here must be a hero. We don't need to write new hero. It's not necessary. Just write new. That's fine. Of course, you could write new hero if you want. Then let's create a bunch of heroes. What's the name? Ah, that's boring. What's the name of Deadpool? Wade. Wilson. Wilson. Thank you. That's Deadpool. And I don't think he can fly. Then a hero that I like. To be honest, I don't know his first name, so let's say string empty, and string empty, and it's Homelander. And Homelander can fly. Any fans of The Boys here in the room? I really like The Boys. So, and a more classical one, Bruce Wayne. Batman, of course, and he cannot fly. Oh, sorry, of course, Deadpool cannot fly. Sorry. Good. Good. Agree? Fine? Good. You can add a lot of different heroes here if you want. The important thing is for our demo, we need to have at least one hero who can fly. The method that I would like to implement together with you based on delegates and lambdas is a method which returns a list of hero which is called filter heroes who can fly, and it gets a list of heroes. So I need to write some code that takes a list of heroes and returns only those heroes who can fly. I encourage you to follow along, although we are going to delete a lot of the code that we are writing now. Okay? We will again use time, we'll take our time to walk step by step towards a modern C# version of this feature. So let's create a result list. This is a new list of hero. Then we will iterate over the list of heroes. I hope you know the for each statement. Var hero in heroes. Then we do an if hero can fly. If the hero can fly, we will add it to the result list, hero. If not, not. And at the end, we'll just say return result list. What do you think? Does it make sense? I think so. Yep. Good. Let's give it a try. We will do the following. We will just call var result filter heroes who can fly. Filter heroes who doesn't work. Filter heroes who can fly and give it our heroes as a parameter. The result will again be a list of heroes because it might happen that multiple heroes can fly. You know what? I will add another hero who can fly. String empty, just to get a little bit more interesting code. Stormfront. True. It's also a female hero from the boys. But you can add Superman if you want, of course. So I will wait for a second until you have followed along. Let's quickly combine that. Var heroes who can fly equals to string.join. Maybe you know this method, maybe not. I will show you what it does. Guess what string.join does? It concatenates the strings and separates the results with a comma and a space. Really convenient method. Did you know that method? Yeah? Some of you did. Maybe some didn't. And then we can just console write line heroes who can fly. Good. Any questions so far? Did we use so far any lambda methods or functions? No. Did we use generics? Yes, we did. Take a close look. Where did we use generics? Just shout out the line number. Where did we use generics? Really? Exactly. Line 16. Or if I scroll up again, here, line 4, list is a generic class. And we want to have a list of hero. We can store anything in a list. And in our case, we give it a type parameter to tell the list that in this case, we maintain a list of hero. That's a generic class. If I take a look at this class, at the definition, you will see exactly the same syntax that you have seen in the code before. T. By the way, do you know how this works? If you want to peek into definition, not directly jump to the class, but take a quick look into how this is declared, you can do that with Alt F12. Alt F12 will give you a quick look into the class. For instance, if I go here to filter heroes who can fly, Alt F12, and it shows you here embedded in your code a quick peek into heroes who can fly. That's really convenient. If you're using some code of you and you want to quickly look at it because you've forgotten how it works, Alt F12, you don't lose the focus here. Does everybody who wants to follow along have this output, and does it work? Yeah. Okay, we will quickly take a look. You know what? I think we now have the big break, right? Yeah, exactly. So let's do 15 minutes break. And of course, I can help you overcome your problems. Do you want to do the break first, and then we'll take a look? Yeah, let's start at the beginning of the lesson. We'll take at your code, and then we will rebuild that stuff to understand lambdas and delegates in this sample, okay? Good.